This is the part 2 of the videos on factors and multiples. So in the part 1, that is the previous video, we learned about the basics on factors and multiples. We learned what is a factor and what is a multiple. So now let's move forward and let's discuss some other points on factors and multiples. So the points that we would discuss here, some points might look familiar to you that we discussed in the part 1. So the first point is that 1 is a factor of every number, and if you remember here, I told you that there would be two fixed factors. There would be two fixed factors always, and that would be the number 1. The number 1 would always be a fixed factor of any number, and the next fixed factor would be that number itself. In this example, we saw for 10 that 10 would be the fixed factor and 1 would be the fixed factor. So similarly, you take any number. I take 22. So for 22, 1 is the factor of every number, and therefore for 22 you can write as 1 multiplied by 22, right? You remember that? And therefore we could say that, hey, 1 is the factor of 22. In fact, you take any number and 1 would always be the factor of any number. You take any number. Next point is that every number is a factor of itself. Same point repeated again. What we saw here, that 10, in this case 10 is the factor of itself, and therefore if you take any number, like say 55, say 1000, or so on, any number, so 55 and 1000 would be the factor of itself, right? If I take 10, then the two fixed factors that is always be there would be 1 and the next one would be 10. The third point is every factor of a number is an exact divisor of that number. And if you remember, we discussed here, right? We discussed that, hey, a factor of any number would be the exact divisor of that number. Exact divisor of that number. And by the exact divisor, what we mean is that exact divisor is the one which always gives remainder as 0. If you divide any number by a number, and if the remainder is 0, then that number would be the exact divisor, and the exact divisor is called the factor of that number. What's the next point? Next point is every factor is less than or equal to that number. So suppose we took example of 12. We took example of 12 here. So what it's saying that if you look at this sentence, it says that every factor of a number is an exact divisor. Sorry, this one. Every factor is less than or equal to that number. So you took for 12, and we saw that for 12 the factors were 1, then 2, then 3, then 4, then 6, and then 12. So these are the factors. Now you could see that the factors are always either smaller or equal to 12, right? Because here you have 12 as a factor, and that is equal to 12. Now 6 is smaller than 12, 4 is smaller than 12, 3 is smaller than 12, 2 is smaller than 12, and 1 is smaller than 12. So even if you take for 10, what would be the factors of 10? It would be 1, that would be fixed one, always 1 is always a factor of every number, then would be 2, then would be 5, and then would be 10. So 10 is equal to 10, and 5 is smaller than 10, 2 is smaller than 10, and 1 is smaller than 10, and that is That is what this point is saying, that every factor is less than or equal to that number, and that holds true for every number. Next point is number of factors of a given number is finite, right? So in this example, you have, how many factors do you have? You have 1, 2, 3, 4, 5 and 6. So you have 6 factors for 12. In this case, you have 1, 2, 3 and 4. You have 4 factors. So if you take any number and if you count the number of factors for that particular number, that number would always be finite. That would always be finite. That means you could count that number. You could count that number. Okay, what's the number of count for the factors? Next point is every multiple of a number is greater than or equal to that number. Very simple. If I ask you, hey, write the multiples of 7. So you would say that, hey, multiples of 7 is 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. And then you will get 42, then 49 and so on, right? So that's, if you see here, your multiple, that is 7 is a multiple of 7, 14 is a multiple of 7, 21 is a multiple of 7, 28 is a multiple of 7, and similarly for other numbers. Now you would see that any multiple of a number, every multiple of a number is greater than or equal to that number. So 7 is equal to 7, but 14 is greater than 7, right? 14 is greater than 7. 21, which is a multiple of 7, is greater than 7. 28, that is multiple of 7, is greater than 7. So what's the difference between the factor and multiple of any number? Factor would always be smaller or equal to that number. The factors of any particular number would always be equal to or smaller to that number, but it's reverse in the case of multiples. Multiples of any number would always be greater than or equal to that particular number. As you could say here, first the multiple of 7 start from 7, so 7 is equal to 7, but then you move on to 14, which is greater than 7. Then you move on to multiple 21. 21 is greater than 7, then to 28, then to 35, and then to 42. Now this is the point number 7, and the point number 7 says that the number of multiples of a number is infinite. So we saw that the number of factors of a number is finite, right? If you remember that we saw for 12, the factors were 1, 2, 3, 4, 6 and then 12. So here you had 6 factors. But if someone says that, hey, go on for, how many multiples you could get for 7? So you would say this is 7 multiplied by 6, 7 times 7, then 7 times 8, and so on. You will go on, then 7 multiplied by 100. Then you would go on and then on, somewhere you would reach 7 times 1000, right? This would be 7000. Then you would go on and somewhere you would get, hey, 7 times 10,000. You would get 70,000. And then you would go on, and it's not going to stop anywhere, because you don't have any largest possible number. A number could be, you cannot even think of that number. It would be larger than what you are seeing here. So that's what it's saying, that the number of multiples of a number is infinite, because it would be 70,000, then it would be 70 lakhs something, then more than that. Okay, so that's infinite. That's infinite. You cannot have the number of counts of the multiples of any particular number. The next point is every number is a multiple of itself. Similar to the case of factor, we saw in the case of 10, and then 12, or any number that the 1 and 10 would always be the multiple of, would always be the factor of 10. 1 and 12, so 12 would always be the factor of 12. So similarly in the case of multiple, so you could see that here you could see 7 is the multiple of 7. Similarly you can write for 8. If you write 8 times 1, you would get 8. So 8 is a multiple of 8. Similarly you could write 9 times 1 is 9. So 9 is the multiple of 9. 10 times 1 would be 10. So 10 would be the multiple of 10, and that's what it's saying, that every number is a multiple of itself. You go on doing this, like 100 times 1. So 100 is multiple of 100. 100 is multiple of 1. So you'll always get this point that every number is a multiple of itself. So these were some points, points concluded from the definition of multiples and factors, and it's very important to keep these points into mind, and that would help you in the future calculations or in future problems. Thanks for watching.